To continue with our discussion for basic electricity, let us look into one of the most important laws in physics, and that is Ohm's law. According to Ohm's law, the voltage or the potential difference is directly related to the current when the resistance is constant. If we are to look into this graph of voltage versus current, you will notice that if we are to plot the graph, we have a diagonal straight line. On the y-axis we have the voltage, on the x-axis we have the current. So we know that if we have a straight diagonal line, we can actually determine the slope. Slope is the change in y over the change in x. So if you are to look into the description of the axis of the x and the y, the change in y is actually the change in the voltage, and the change in x is the change in electricity. The slope of the line is the resistance. We are now looking into this new quantity, which is known as the resistance. Now, what is resistance? Let us now look into the equation for Ohm's law. So the equation is V is equals to I multiplied by R. So we know that V is the potential difference, which is in voltage. I is the electricity or current. R is the resistance. So if we are to rearrange this in terms of R, we will actually have this equation. V is equal over I. So looking into this relationship, notice that R is in the same position as the voltage. Now what does this one mean? The higher the resistance, the greater force we need. So what I'm saying in here is that the R is directly proportional to the V. An increase in the R would mean an increase in the V. Why? R is resistance. So if the material offers a lot of resistance, we need to have a lot of electromotive force in order for us to be able to produce electricity. So therefore, we need to overcome this resistance by increasing the voltage. Now, what about the relationship between the R and the I? And here we notice that the R is a numerator and I is the denominator. So meaning, if you increase the R, you decrease the electricity. Does that make sense? It makes sense because if you have a great resistance, the flowing of the electrons will be slowed down. So if the electrons flow is somewhat limited, the electricity that will be produced will also be limited. So in effect, what I'm saying here is that the R is inversely proportional to the I. So what does this one mean again? If you increase the I, the R is decreased. So the higher the resistance, the smaller would be the I. So please take note of this relationship. It really will help you a lot when you are analyzing equations or problems. Let us look into this resistance. Notice that the key word for resistance is resist. To resist means to oppose. Now what are we opposing here? If you recall, electricity is simply the flow of electrons. In order for the electrons to flow, the electrons need a conductor. When we were looking into the conductors, we learned before that metals are very good conductors of electricity. Now, why is it that metals are very good conductors of electricity? The reason, metals have few valence electrons. So the valence electron of metals ranges from 3 to 1. So since the electrons are very few on the outer energy level, this valence electron could actually move freely, really fast. So therefore, the flowing of electrons could easily be facilitated by just introducing even a very small amount of potential difference or voltage. Now, each metals, based on their position in the periodic table, has a different number of valence electrons. So since the valence electrons are the ones that is actually transferred from one point to another, the number of the valence electron of a metal determines how good a conductor that metal is. So let us now look into this resistance again based on the interactions in the atomic scale. Let us look into these two models of an atom. The atom on the left has 3 valence electrons. The atom on the right has 1 valence electron. Now we know that electrons has negative charge, so therefore between the electron and the positive nucleus there exists an attractive force. Since we have in here 3 valence electrons that are moving in the same energy level, the movement of the electrons here is somewhat limited. So although this could still conduct electricity, the movement of the electrons is somewhat limited because aside from we have 3 electrons in the same energy level, we also have a greater number of negative charge that would be attracted to the positive center. So the electromotive force or the electrostatic force that exists between the valence electron and the positive nucleus is very strong. So even if there is a force, an electromotive force that is pushing this, the force is somewhat being limited. The movement of the electrons is limited because there is also a force that exists, an attractive force that exists between the nucleus and the electron. Because of this other force that is existing between the the nucleus and the electron, this electromotive force in here is being opposed by this. So the movement of the valence electron is somewhat limited. So these limitations on the movement of the electron is known as resistance. So the greater the resistance, the smaller amount of electrical energy will be produced. In comparison, let us look into this atom on the right side. We only have one valence electron occupying this energy level. Remember that the electrons are always moving. They move and also spin at the same time. So the manner of motion of the electrons is actually a spinning motion and also a circular motion. So since this is by itself, even though this one is negative and this one is positive, even though there is in here an attractive force that exists between the electrons and the protons, the force is not as strong because this one is moving really fast. So therefore, if we are now to introduce a potential difference, which is our electromotive force, this electromotive force could easily move this proton and cause this to move to other atoms. So it would be a lot easier for this electron to transfer from one atom to another. So the force that somewhat inhibit these electrons from moving is very, very limited. So the resistance that is being offered is very small. So less resistance, greater amount of electricity produced. The resistance that I just described in the previous slide is the resistance that is offered by the conducting wire. The real resistance that we have to look into in this topic is the resistance that is offered by the load. Resistance in the load is actually a lot higher than the resistance that is offered in the conducting wire. This is the reason why if we are to draw the circuit diagrams, the load is actually labeled as resistor. Another important term that we have to look into in the study of electricity is the power. We have learned that power is the rate at which work or energy is done. Circuits that are prime example of this, as batteries only last for a certain amount of time, and we get charged an energy bill each month based on the amount of energy we use over the course of month. Sometimes we actually call that as power. Let us look into this illustration. This illustrates how electrical energy is transferred from the power plant to our house. Notice that from the power plant we have a transmission substation, and then these are connected to high voltage transmission lines. And then we also have a power substation and a transformer. Its line in here carries very, very large amount of electricity. So that if you will notice, each of these power poles, there is in here a wire that is connected to the ground. It serves as a ground. And have you ever wondered why, if this one is really high voltage, why is it that birds that are actually resting on these power lines are actually not electrocuted? The reason is that the birds actually, when they rest on this, they actually their feet is actually the feet of the birds actually touches the power lines exactly at the same time. So there is in here no potential difference between the feet of the birds. So there will be no electricity that will be produced to that will hurt the birds. Now, since this one is very high powered, in order for the electricity to in order for the house to be able to use the electricity, there should be a transformer. So this one somehow lessen the amount of electricity that will flow to the house. Otherwise, if we are to just uh, get the electricity from here without passing through a transformer, our appliances will overload. Let us look into the power in relation to Ohm's law. If you recall, potential difference is simply the amount of energy divided by the charge, and electricity is the charge divided by time. And from Ohm's law, we have in here voltage times I is joules multiplied by columns and second, columns and columns cancels out. So what is left is joules per second. Now joules per second is actually watt. Watt is the unit. SI unit for power. So therefore, power is equal to the product of the voltage and the electricity. So looking into these equations, remember that power is the product of the voltage in the I, and from Ohm's law, the voltage is equal to the product of I and R. So if we are now to consider these equations here, if we plug in the value of the voltage to this equation, so power would become V is equals to I times R multiplied by I. So I and I would give you I squared and then R. So this is a useful equation to solve for power if you know the electricity and the resistance. If we are to rearrange the Ohm's law, I is equals to V over R. So therefore, we have an I in here. So instead of writing I, we plug in the value of I, which is V and R. So therefore, power would be V multiplied by V over R. V and V is equals to V squared divided by R. So in effect, we have in here three equations that are very useful to solve for power. First is P is equals to VI. Second, P is equals to I squared multiplied by R. Third, P is equals to V squared over R. To summarize the equations, let us first look into Ohm's law. V is equals to I times R. If you are to fit that in a triangle, we can rearrange this to solve for I. So you have I is equals to V over R, and R is equals to V over I. For power, we have these three equations. Remember that V is the potential difference or voltage. Unit is V or voltage. I refers to the current or electricity. Unit is amp or simply A. R refers to resistance, which is in ohms with this symbol. P is power, which is in watt. 1 kilowatt is equal to 1,000 watts. Please copy this in your notes because this one is not included in your PowerPoint slide. Let us now try to apply what we learned in problems. Let us analyze this problem. So reading this together, it says here, find resistance through a 12 ohms resistive circuit when 24 volts is applied. Let us apply what we learned. But before that, please replace or cross the resistance out. This should read current. So let us now read the problem. Find the current through a 12 ohms resistive circuit when 24 volts is applied. So what are we given? First, let us look into this quantity which says 12 ohms. Now notice that the quantity with the unit of ohms is actually our resistance. So therefore, RR is given as 12 ohms. You can use this symbol for ohms. The next one that is given is 24 volts. And we know that the quantity with the unit of volts is the voltage. So that is simply V. So we have 24 volts. So what are we looking for? We are looking for current, which is represented by I. So what equation are we going to use? Going back to Ohm's law, V is equals to I multiplied by R. And remember that if we fit this in a triangle, we have V on top, I on the left side, R on the right side. So if we are looking for the I, we simply divide V by R. So this is our equation. Okay, to continue, let us plug in the values. So again, our equation is V over R. So our V is 24 and our resistance is 12. Notice that we don't have to do anything to convert the units because the given units are already the proper SI units for the voltage and the resistance. So therefore, by simply dividing 24 by 12, this gives us 2 amps. This is our answer. Therefore, the current is 2 amperes. For problem 2, if you will notice, this one is similar to problem 1 because we're also given 600 ohms and we know that ohms is resistance. and also the voltage, which is V. So we are actually just looking also for the current. So I leave you responsible to solve for number 2. Let's move on to the next one. Okay, problem number 3 states that find the applied voltage of a telephone circuit that draws 0.017 amperes through a resistance of 15,000 ohms. So what are we given here? We are given 0.017 amperes. So we know that the ampere unit is for current, so we are given I, which is 0.017. Write down the unit A. And the unit ohms refers to the resistance, so we are given the R. So we have 15,000 ohms. It says here that we are to find the voltage. So we're actually looking for V. So what equation are we going to use? So the equation is simply the original form of Ohm's law. So which is V is equals to I multiplied by R. Let us plug in the values. So V is equals to I multiplied by R. So therefore, we have 0.017 multiplied by 15,000. This one will give us 255. What's the unit of voltage? Simply V. So that is our answer. Now let us look into the last problem. It says here, a blender is plugged into a 110 volt outlet that supplies 2.7 amperes of current. What amount of power is used by the blender? So using the guess method again, let us write down the given. So we know that 110 volts refers to the voltage. So just write down V is equal to 110. And current is also given as 2.7 amperes, and we know that current is represented by I. So you have 2.7 amperes. What are we looking for? We are looking for power. So you write down P for the unknown. So what equation are we going to use? Of the 3 equations for power, the first one is the best one. So you have P is equal to V multiplied by I. Okay, so let us plug in the values. P is V multiplied by I. So therefore V is 110 and I is 2.7. That will give us the power to 97. What is the unit of power? It is watts. Let us try to solve also for resistance. What if we are asked to solve for R? Using the equation for power, we have this equation, P is equals to I squared multiplied by R. So we can actually fit this in a triangle. So you have P, you have I squared, and then R. So if we are looking for R, what would be our equation? So R would be equal to P divided by I. So RP is 297 divided by the square of I, which is 2.7. You square that. RR will be 40.74. The unit is ohms.